question 5.4. Write down the domain of G. And I hope you realize when we talk about the domain, we're dealing with the x values. So it's asking what are the values of x for which G, which is our graph that we're dealing with, will interact with and cut. And also make sure that you don't get confused. You don't go to the top and say, oh, well, here's our G of x. We can see our domain, easy peasy. No, we're dealing with G of x that we just created, which is minus f of x. So now it's a bit trickier. We need to be able to see how does f of x change when a minus is put in front of it. Well, first let's write down our g of x. G of x is equal to minus log 3 of x. So you can either learn this, and that's what I liked to do, and then I would understand it. But I'm going to explain quickly what's going on here. Remember, g of x is also your y value, because this is a function. We're putting in an x and spitting out a y. It's a machine. So if suddenly there's a minus in front of here, for whatever value log base 3x calculated, let's say it was 2, it's suddenly always going to become minus 2. So inevitably, your y value is just going to flip. It's just going to become a negative reciprocal. Not negative reciprocal. It's going to become times minus 1. So if our graph had looked like this, suddenly we're dealing with, okay, well, this value needs to go here, and this value needs to go here, and this value needs to go here. Suddenly you deal with a completely new graph that would look something like, take these dots away, something like that. It's just flipping about the x-axis because all your y values are suddenly becoming negative. So on our graph, and I'll try to draw it nicely here, if for, let's say this was 1, and you go down here, it tells us right here, 1/3 spat out -1 in the original f of x. But now there's a minus in front of our f of x. So our minus 1 y value suddenly turns to a plus 1. So it actually goes, the new s point is over here. So it just swaps every value. Oh, no. Every value will suddenly swap. The y value will be times by minus 1. So I hope you can see what our graph would look like. It would look something like this. Well, that's so poor. Would look like something like that. Suddenly you have an asymptote over here, and you have your exponential moving up like this. So its domain, I just want to try to draw this better. There we go, that looks better. There we go. What is our new domain now? Okay, well, if domain has to do with x, the x-axis, we can clearly see that our new asymptote is still our original asymptote because all it's done is flip to the top. And our x value cuts every single x in the positive direction, but none in the negative region. So our new domain will be equal to 0, positive infinity. Let me make sure. Yeah, 0, positive infinity. Exactly right. So just to make sure that you grasp that, our f of x graph was times with a minus 1. So every y value that this spits out will be times with a -1, thus flipping every value we originally had about the x-axis, creating an entirely new graph. So you could plot it if you really wanted to and then figure out some sort of pattern, but it's really important to know just that the swap of a log graph when it's times by -1 will just be a swap like this. This is theory that's very useful. Swap just like that. So you have your new asymptote over here. your asymptote's always here. It's never going to cut x, but your asymptote runs off, diverges in that direction. Well, it doesn't diverge. It approaches 0, sorry. But yes, that is the problem solved.